Celebrate Thanksgiving with Safeway. This week at Safeway, get whole Signature Farms frozen turkey, 10 to 15.5 pounds for $8 each, or 16.1 to 22 pounds for $10 each. Member price with a minimum $50 purchase, limit one per household. Plus, packs of Coca-Cola, Pepsi, 7-Up, Dr. Pepper, or AHA Sparkling Water are buy two, get three free. Limit 3 free items. Also this week, get 5-pound bags of Signature Farms russet potatoes for 97 cents each with digital coupon. Limit 1. Visit Safeway.com or head in store for more details.
Well. Shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
This is SpaceTime Series 25, Episode 67, for broadcast on the 20th of June 2022. Coming up on SpaceTime, evidence that the Earth's inner core oscillates, a new look at planet Earth's tectonic plates, and NASA to study UFOs, just as China claims it may have picked up signals from an alien civilization. Then again, maybe it didn't. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered that the Earth's inner core oscillates, contradicting previously accepted models, which suggested that it constantly rotates at a faster rate than the planet's surface. Based on an analysis of seismic data, the new findings, reported in the journal Science Advances, shows that the inner core actually changed direction over a 6-year period between 1969 and 1974. The new model for the inner core's movement would also explain variations in the length of a day on Earth, which has been shown to oscillate persistently for the past several decades. One of the study's authors, John Vidal from the University of Southern California, says the findings confirm that the Earth's surface shifts compared to the inner core, just as some people have asserted for more than 20 years now. The new observations showed that the inner core spun slightly slower from 1969 to 71, then moved in the other direction from 71 to 74. And the length of day grew and shrank as a consequence of this change. Vidal believes the consequence of these two observations makes oscillation the likely interpretation. Science's understanding of the planet's inner core has expanded dramatically in the last 30 years. The inner core is a hot, dense ball of solid iron, about the size of the dwarf planet Pluto, and it's been shown to move and change over decades. Trouble is, it's impossible to observe directly because it's at the center of the Earth. That means scientists need to struggle through indirect measurements in order to explain the pattern, speed, and cause of the movement and changes. Research published in 1996 was the first to propose that the Earth's inner core actually rotates faster than the rest of the planet, also known as superrotation. It equates to roughly 1 degree per year. Subsequent findings by Vidal reinforced this idea, but at a somewhat slower rate. Utilizing data from LASA, the Large Aperture Seismic Array, a U.S. Air Force facility in Montana, Vidal and colleagues found that the inner core rotated slower than previously predicted, a rate of approximately 0.1 degrees per year. That study reached its conclusions by analyzing seismic waves generated by Soviet Union underground nuclear weapons tests between 1971 and 74. These tests were conducted in the Arctic archipelago, and the readings were achieved using a novel beamforming technique developed by Vidal. The new findings emerged when Vidal and colleagues applied the same technique to data from a pair of earlier Russian atomic tests conducted in 1969 and 71. Measuring the compressional waves resulting from those nuclear explosions, they discovered that the inner core had reverse direction, sub-rotating at least 1/10 of a degree per year. This latest study marks the first time this 6-year oscillation has been indicated through direct seismological observations. Vidal says the idea that the inner core oscillates was a model that was already out there, but the community had been split about whether or not it was viable. He says he went into this study expecting to see rotational direction remain the same and the rate which was found in the earlier pair of atomic tests. But instead he saw the opposite and was quite surprised to find that the core was moving in the other direction. Future research will depend on finding sufficiently precise observations to compare against these results. By using seismological data from atomic tests in previous studies, they've been able to pinpoint the exact location and time of the very simple seismic event. However, LASA closed in 1978, and the era of American underground atomic bomb testing is also over. That means research now will need to rely on comparatively imprecise earthquake data. The study does support the speculation that the inner core oscillates based on variations in the length of the day, plus or minus 0.2 degrees over 6 years, and as a result of geomagnetic fields, both of which match the theory in both amplitude and phase. Vidal says the findings provide a compelling theory for many questions posed by the research community. It suggests that the inner core is not fixed. It seems to be going back and forth a couple of kilometres every 6 years. One of the questions still waiting to be resolved is whether the inner core progressively moves or whether it's mostly locked compared to everything else in the long term. And then there are the basics, such as how the inner core formed in the first place and how it moves over time. This is SpaceTime. Still to come. And you look at planet Earth's plate tectonics, and NASA to undertake its own independent study of unidentified aerial phenomena, better known to you and I as UFOs. All that and more still to come on SpaceTime. Scientists have developed new models providing a more detailed view of planet Earth's extensive system of plate tectonics and how the continents are assembled. The findings, reported in the journal Earth Science Reviews, are providing fresh insights into the history of the Earth and will provide a better understanding of natural hazards, like earthquakes and volcanoes. The study's lead author, Derek Hasterrock from the University of Adelaide, says the research looked at the current knowledge of the configuration of plate boundary zones and the past construction of the continental crust. He says the continents were assembled a few pieces at a time, a bit like a jigsaw puzzle. But each time the puzzle was finished, it was cut up again and reorganized to produce a new picture. The new research helps illuminate the various components so geologists can piece together the previous images. The authors found that the plate boundary zones account for nearly 16% of the Earth's crust and 27% of continents. The team produced 3 new geological models: a plate model, a province model, and an orogeny model. Hasterrock says there are 26 orogenies, the process of mountain formation, that have left an imprint on the present-day architecture of the crust. Many, but not all, are associated with the formation of the supercontinents. This work allows scientists to update their maps of tectonic plates and the formation of continents. These plate models, which have been assembled from topographic models and global seismicity, haven't been updated since 2003. The new plate model also includes several new microplates. Among them, the Macquarie microplate, which sits south of Tasmania, and the Capricorn microplate, which separates the Indian and Australian plates. To further enrich the model, the authors also added more accurate information about the boundaries of deformation zones. Previous models only showed these as discrete areas rather than wider regions. But the biggest changes to the plate model have been in Western North America, which often has the boundary with the Pacific Plate drawn as the San Andreas and Queen Charlotte Faults. But the newly delineated boundary is much wider, approximately 1,500 kilometres across, and far wider than the previously drawn narrow zone. The other large change is in Central Asia. The new model now includes all the deformation zones north of India as the plate bulldozes its way into Eurasia. Hasterrock says the new model for tectonic plates better explains the spatial distribution of 90% of earthquakes and 80% of volcanoes from the past 2 million years. whereas previous models really only captured around 65% of earthquakes. And so this results in a far more accurate representation of the Earth's architecture. He says the new plate model can be used to improve models of risks from geohazards. The orogeny model can be used to understand geodynamic systems and better model the Earth's evolution. And the province model can be used to improve prospecting for minerals.
What we're doing is trying to put together a seamless model of several different observables on the Earth. One is where are tectonic plates and the deformation zones. Another is the types of geologic provinces. So that's things like where volcanic arcs are, where orogenic systems are, and what types of crust there are. So a lot of these models actually exist out there already, but one of the problems is that they don't sort of all overlap. So when you're trying to figure out what type of data point you have that you've collected someplace, and you use all of these different maps, you get some very bizarre combination of things. Like you find something that might be an island arc that sits in the ocean, which doesn't make any sense, or a continental arc that sits in the ocean or something that doesn't make any sense. So we wanted to sort of resolve some of those issues by developing this sort of seamless map, but it also gave us the opportunity to look at things like orogenic systems and come up with a better way to define what these orogenic systems are and what the various parts are, and then look at how they fit together through time.
So what is an orogenic system?
So an orogenic system, an orogen is a mountain belt. Okay, so it's an orogeny is the process of building mountains, and so there's a couple of different ways that orogens are built in the Earth. One is that you can have two continents that collide, so something like India colliding with the Himalaya or with Asia creates the Himalayas. You can also have orogenic systems like the Andes, where you have a oceanic plate that's subducting beneath continent, and you can have oceanic plate that's subducting beneath ocean and creating an island arc system like the Izu-Bonin arc or the Marianas Trench or Marianas arc, that sort of thing. So there's several different ways that you can create orogenic systems, but orogenic systems are really important for understanding how the continents have been built over time, because that's effectively how you store continental crust. Is you basically have to smash things together and push part of it up over other crusts to sort of preserve it for a longer term. And it's also places where you create ore deposits, and it's important for affecting the way climate behaves, because mountains actually create natural barriers to the flow of air, and where continents are affect the way the ocean circulation happens. So orogenic systems are sort of a really important process on Earth, and they're not just important for the physical behavior of the Earth, but they're also important for things like life, because they sort of break up the continents and create various ecological niches for biodiversity. And of course, they've been important throughout human history for things like creating natural barriers to prevent one army from easily attacking a different nation state or something like that. So mountain building systems, and understanding these origins and where they are and how they're built is sort of really interesting and really important part of understanding our world.
You did find some interesting microplates. Tell me about them.
Yeah, so there are a number of microplates that exist. So what a microplate is a small, you can think of it as like a small tectonic plate. It's rigid on the inside. On the outside, it's sort of ringed by earthquakes and maybe volcanoes, or maybe it has a few internal volcanoes or something, but it's ringed generally by faults that allow earthquakes to happen. And these microplates behave like a tectonic plate, only sort of in miniature. Now, what makes a microplate different than a large rigid plate is that a microplate is controlled in some ways by the major plates on either side of it, and it doesn't move independently, whereas a major plate like North America and the Pacific move independently of each other. But in between them, there's a lot of microplates that are controlled by the motions of those two. So, for instance, there's one that goes up through the Sierra Nevada that acts the same way. Near Australia, there's the Capricorn microplate, which is a microplate that sits between India and Australia, and it's a large sort of extensional zone that sort of accommodates the motion between the Indian and Australian plate. It may not actually be a microplate, so it doesn't quite behave like a tectonic plate with deformation just at the edges. It actually has deformation scattered all throughout. And so it's actually more of a deformation zone. So you have these two types. You have this sort of microplate and a deformation zone that accommodate some amount of the plate motion between the major plates that everyone's familiar with, like the North American plate, the Pacific, the African, things like that.
And I guess microplates are important when you consider things like the Indian Ocean tsunami.
That's right, because a lot of these microplates take up large amounts of the deformation between the plates. And so that's where a lot of the action is really happening. Most of your earthquakes are happening within these deformation zones. About 80 to 90% of earthquakes fall within these deformation zones and microplates. So they really control what's happening tectonically.
I remember at school we were taught that the Earth's tectonic plates are moving at about the same speed as what fingernails grow, roughly 3 centimeters a year. But that's not quite true, is it? Because different plates are moving at different speeds. And I understand that the Australian plate is pretty well setting records as it moves in a northerly direction.
That's right. The Australian plate is actually sort of like a race car in a sense. It's really barreling north into Papua New Guinea and beneath the sort of band of subduction zone. It's actually really unique too in some ways because we're actually starting to subduct continental crust. Sort of pushing that continental crust down into the mantle, which is fairly unusual. What makes it even more unusual is that we're forcing it down beneath an oceanic plate on the sort of banda side, which is not something that we see really anywhere else. Most places you might have a little bit of continental subduction just beneath another continent, but not usually beneath an oceanic plate.
Okay, important question. Whose continental crust are we subducting? Australia's or something further north?
It's Australia's continental crust.
Oh, we're getting smaller.
That's right. We're getting smaller. But actually, it creates some really interesting effects, too, because I've been looking at some of the other work that I've been doing. We've been looking at how the subduction of continental crust affects the amount of uranium, thorium, and potassium that's produced in volcanoes. And so the volcanoes that come out above the Australian plate where it's subducting create very high heat producing or very radiogenic volcanoes. So sort of extra hot, one might say.
For our listeners, there's a big difference between the continental crusts and the basaltic crusts you find on the ocean floor, and in terms of their chemical composition, in terms of their density. And so as continental crust subducts, you'd have very different sorts of pressures and temperatures created would cause very different effects compared to the oceanic crust subducting, which is what you'd normally expect.
Yes, that's right. Oceanic crust is mostly made of what we call basalt, which is a fairly dense volcanic rock, whereas the continental crust has a lot of granites and things like that, the sort of lighter color rocks, and they have relatively low densities. So they don't actually like to subduct. So usually when they do get pushed down into a subduction zone, they'll subduct maybe a small distance into the mantle before their buoyancy is just too much. It's like trying to take a soccer ball or something like that as a swimming pool and trying to push it into the water. You can push it into the water a little bit, but the farther you try and push it, the more it wants to come back to the surface. And so the continental crust does the same thing. You can sort of push it down a little bit and then it pops back up and will sort of stop subduction. So usually once the continent starts getting subducted, you're getting close to the end of subduction on the other side. And so Banda and Papua New Guinea will probably sort of cease subduction, at least in some capacity, in the near future.
That would increase the amount of volcanic activity too, wouldn't it, when this material tries to make its way back to the surface?
Yeah, it very well could increase the volcanic activity because what happens is as you push it down, you're pushing something cold into something warm. Eventually that'll warm up, and because it's at the surface, it tends to have a lot of water mixed in with the rocks or even bound in the minerals. Those minerals and things will start to melt much more easily, and so you can actually have big magmatic flare-ups. And often you can have those tens to even 100 million years after an orogenic process, just because it takes that long for the heat to heat the rocks up enough. And we certainly see that in Tibet today. There's still plenty of volcanism out in the central Tibet as a result of these sort of long-term continental subduction type processes.
Is Zealand another example of one of these orogenies?
Yes, actually, it's actually an old orogeny that started during Gondwana time. So that's the supercontinent just before Pangaea. There was a subduction zone that went all the way from Australia around Antarctica and South America. So the Andes today are remnants of their subduction zone. It's no longer operating in Antarctica, and it's actually torn much of Australia apart. So it sort of was responsible for these. It was almost actually like an accordion, the way it put Australia together and tore it apart in several episodes. And one of those episodes rifted off Zealandia, which is sort of thinned continental crust that used to be part of Australia. And New Zealand and Tonga have been sort of further rifted and continuing to rift off of the Australian plate farther into the Pacific as a result of this long-lived subduction zone.
That's Derek Hastrock from the University of Adelaide. And this is SpaceTime. Still to come, NASA to undertake a study of UFOs, just as China claims it may have picked up signals from an alien civilization. Or maybe it didn't. And later in the science report, Neurodevelopmental issues have been found in some children born to mothers with COVID-19. All that and more still to come on SpaceTime. NASA is to undertake its own independent study of unidentified aerial phenomena, better known to you and I as UFOs. Of course, this is a subject which has long fascinated the public, and recently it's gained high-level attention from Congress. Last month, Congress held public hearings into UFOs, while a US intelligence report last year catalogued 144 sightings that it said could not be explained. NASA will focus on the scientific perspective. It'll identify available data, how best to collate future data, and how that information can be used to improve scientific understanding of the phenomena. UFOs, or UAPs, unidentified aerial phenomena as they're now called, are simply observations of events in the sky that cannot be identified easily as aircraft or other natural phenomena, like funny-looking clouds or birds or the planet Venus, for example. Because of their nature, they're of interest both in terms of national security and air safety. Establishing which events are natural provides a key first step to identifying or mitigating such phenomena. And this aligns with one of NASA's key goals, which is to ensure safety of aircraft. NASA's study will be independent of the Pentagon's Airborne Object Identification and Management Synchronization Group, even though traditionally UFO investigations have always been left to the military. It all started during the height of the Cold War and following the infamous Roswell incident. The US Air Force eventually launched Project Blue Book, a formal investigation by the Pentagon into claims of flying saucers and other paranormal phenomena. Project Blue Book investigations, undertaken by astronomers and Air Force aviators, ran from March 1952 through to December 1969, and they tried to determine what UFOs were and whether they were a threat to national security. All in all, Project Blue Book collected some 12,618 UFO reports. It concluded that most UFO sightings were either misidentifications of conventional aircraft or natural phenomena such as clouds, stars, or the planet Venus. There was no evidence that any of the sightings categorized as unidentified were extraterrestrial in nature. No Greys, no Klingons, not even an Ewok. Project Blue Book concluded that the investigation of UFOs was unlikely to yield any major scientific discoveries. You see, nothing was found that represented technological developments or principles beyond the range of modern scientific knowledge, and the investigations yielded no evidence of any threat to national security. Ultimately, Project Blue Book concluded that UFO sightings were generated as a result of misidentification of various conventional objects. There were some cases of a mild form of mass hysteria, others where individuals would fabricate reports that perpetuate a hoax or seek publicity, and of course there were people suffering from psychological issues. That's about it. Some decades later, the National Reconnaissance Office finally confirmed that many so-called UFO reports were actually flights undertaken by formerly highly secretive U-2 spy planes or the A-12 SR-71 Blackbird reconnaissance aircraft. Still, even when these were taken into account, some 701 reports were still classified as unexplained. NASA Associate Administrator for Science Thomas Sabukin says the space agency has powerful tools both on the ground and in orbit which will be utilized to find answers. The project, which is expected to last about 9 months, will be headed up by NASA astrophysicist David Spergel. It'll collect and analyze data from civilians, from government departments, from non-profit organizations such as MUFON, and it will employ experts in science, aeronautics, and data analytics. Importantly, consistent with NASA's principles of openness, transparency, and scientific integrity, the report will be shared publicly. Now, at the same time as all this was being announced in Washington, on the other side of the planet, the internet was abuzz with claims by China that it had picked up signals from what appeared to be an alien civilization. The claims are based on reports from teams at FAST, the 500-meter aperture spherical radio telescope located in southwestern China's Guizhou province. One report, which was published by the state-backed Science and Technology Daily, that's the official newspaper of China's Ministry for Science and Technology, claims two sets of intriguing signals were picked up in 2020 while sifting through fast data initially gathered in 2019. And then a third signal was apparently picked up this year in data gathered by FAST while looking at exoplanetary targets. But others are saying not so fast. Dan Wertheimer from SETI, the Search for Extraterrestrial Intelligence, and the University of California, Berkeley, says the signals are simply regular radio interference due to radio pollution generated by things like cell phones, TV transmitters, radar sets, satellites, and electronic devices near the observatory, and they're not being generated by ET. You may recall a few years back the Parkes Radio Telescope in Australia picked up some strange signals. They turned out to be the microwave oven in the commissary. But then again, back in August 1977, a SETI search performed by the Ohio State University's Big Ear Radio Telescope picked up a 72-second-long extraterrestrial signal that was so strong and so unusual, astronomers circled a printout of the signal data, writing the comment "wow" next to it in the margins in red pen. For years, the now infamous Big Wow signal was thought by many as the most promising sign of possible extraterrestrial intelligence. But the signal, which originated in the HD 164595 system, has never been repeated, nor has anything else like it been observed since in that or any other part of the sky. And so the signal and its significance has long since faded into history. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that babies born to mothers that had a COVID-19 infection while pregnant in 2020 were more likely to receive a neurodevelopmental diagnosis during the first year of life. The findings, reported in the Journal of the American Medical Association, are based on data covering some 8,000 infants, 222 of whom had mothers who tested positive for COVID-19. The research indicates the trend showed up when the mother got sick during the third trimester. Most of these diagnoses involve developmental disorders around motor function or speech and language. The authors say follow-up studies are now crucial in order to confirm the link. Some 6.4 million people have now been killed by the COVID-19 coronavirus since it first appeared in the area surrounding China's Wuhan Institute of Virology back in September 2019. However, the World Health Organization believes the true death toll is likely to be around 15 million, with over 542 million confirmed cases globally. A new study has linked vitamin D deficiency to dementia. Dementia is one of the major causes of disability and dependency among older people worldwide, affecting thinking, memory, and behavior as one ages. Now, a report in the American Journal of Clinical Nutrition shows a link between vitamin D deficiency and dementia, with additional genetic analysis supporting the idea that there is a causal effect. Paleontologists have identified the remains of what could be Europe's largest ever dinosaur, a 10-metre-long Spinosauroid which roamed what is now the Isle of Wight around 125 million years ago. The giant crocodile-faced theropod, named the White Rock Spinosauroid after the geological layer in which it was found, was identified from a series of fossilized bones, including huge pelvic and tail vertebrae. The findings, reported in the journal PeerJ, were originally unearthed on the south coast of England. A chilling image has surfaced on social media showing what appears to be the haunted face of a dead child staring out of the window of an abandoned Irish lunatic asylum. The spooky photo has been dismissed by skeptics as a case of pareidolia, the human brain seeing faces in inanimate objects, like seeing the face of Jesus on a slice of toast. Tim Mendham from Australian Skeptics says the image was captured by a group of paranormal supernatural investigators who were visiting the former Our Lady Psychiatric Hospital in Ennis, which was home to thousands of patients between its opening in 1868 and its closure in 2002.
In the Skeptics and me especially, I get information every day. I mean, literally every day of photos of ghosts that are sort of, the genuine article, this is it, proof positive, blah, blah, blah. And you look at them and you think, really? That's pretty much weird. I get things where I can't see anything in them. I had someone who sent me pictures of fairies in close-ups on grass, and I think, nope, nothing there, mate. These photos come in all the time, and they're inevitably either obvious hoaxes, and some of them pretty easy to tell, or there's just nothing there and it's your imagination, pareidolia, etc. You see shapes and pictures where there isn't any existing. Most of them are disappointing. We got one in recently. We had one of many thousands that came in recently of a ghost of a dead child spotted in the window of an abandoned asylum. And this is the usual thing, sort of paranormal investigators go out there to a spooky building. They go out there at night. I don't know why they go at night, but never mind. They go out there at night, take lots of photos, bring the photos home, and then scour them and say, look, there's a ghost, right? And which they didn't notice at the time, but they see it on the photos. And this particular one is of a roughly human face looking through a window. If it is a human, it's a pretty ugly kid. The head is all distorted, etc. And you use your imagination to see a face in there. Actually, I've also been described as a puppet. It looks like a glove puppet or something like that. But I mean, it's basically seeing a shape where there isn't any. And human faces are the easiest thing to try and spot. Or the most common thing to try and spot when you're looking at sort of weird shapes, shadows, messy bits of glass.
Brains are wired, aren't they?
It is. That's exactly how the brains are wired, and that's because we want to recognize faces. We want to see a face, and therefore you see faces in everything you look at. PowerPoint is a face, that sort of thing. So this psychiatric hospital, which everyone agreed was a pretty spooky place. It was horrible. It was overcrowded. All the usual things you think of Victorian era, what was then called lunatic asylums, and even this one was in use up until not that long ago. They're horrible places, so they already start off with an atmosphere. So you're inclined to look for something, and therefore what you do is you tend to find something when you're looking for something, and especially with ghost photos and things like that. So that's what this is. It's not a particularly good one. There's one of many we see all the time. People see rough shapes, especially in windows and things. Most of them are actually a bit better than this one. It's more like an actual human. This looks, as I said, like a glove puppet, whatever. But people will see shapes and faces all the time with these ghost photos and things, and everyone says, every newspaper, of course, waxes lyrical at the moment. Shock, horror photo, blah, 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 definitive proof, here it is, ghosts are real, and then I'll move on to the next one as soon as that one's over. So far, there have not been any photos that are definitive of ghosts. People would still submit them all the time and say, this is the one, and you're stupid, you just don't believe, etc. But this particular one, no.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.